So, and anything in between. If you search heart rate variability and something medical, you will find somebody did research on it. So they have, what I make my students do, find a paper where somebody did research on that, and then they have to create an instrument that lets somebody else reproduce that research. They don't have to do the research, they just have to make. So the big problem with that is if in one semester, most medical instruments today are about 10 or 15% hardware and about 85% software. And if you try to make somebody write all the code for even something that simple, it can take a long time. So what we do is we look, at least I did for a long time, and what now people are realizing is computers actually can make software a lot faster than you can, all right? And so that, by the way, so that's why one reason that enrollment in computer science in most colleges is going, if you don't realize that, no. I'm looking to see what they have me wired up with. Anyways, so I had hoped, I've run a seminar like this lots of times, mostly at Northeastern for students, so like a 1 or 2 hour. What I really would like, and what's not gonna happen today, is that each one of you have a laptop and can run the example that I'm gonna run, and Elizabeth over there, we're the only 2 people right now. The problem is that to download all the software you need to make this happen, at Academic City, it takes about 4 or 5 hours to download the software just to get it to run, because it's like somewhere between 10 and 20 gigabytes. It's all MATLAB, Simulink, and Simulink add-ons. I'll show you another way that at the end that you can create software quickly. The problem with it is it makes you think more like a programmer and not like an engineer. And the reason I like doing it this way is because how many of you write either like what a block diagram for something you're trying to design? You know, like this is the block that acquires data, this is the block that sends the data, this is the block that takes the data and displays it. How many of you have made some kind of simple block diagram like that? Yeah, it's most, okay, let me back up. How many of you are engineers? And what are the people who are not engineers here? Who's not an engineer? Raise your hand. So what's your background? Because what we're going to do is simple enough so that everybody, whether you're an engineer or not, should be able to understand the little program we're going to make today. So what's your background? What kind of? But so you're an engineer. No, I said, who's not an engineer? And you said medical. So you design experiments to do things, right? So you've made diagrams of what your experiment is supposed to do. You make some kind of plan. Is some of the plan a graphical design? It's not just words. So that's kind of, what we're doing is making something, you can think of it as a graphical flow diagram of what we want a system to do. You can think of it, if you're a computer scientist, you can think of it as a graphical programming language. So instead of writing words, you're making blocks, and the blocks turn into what is called C code. If that's just a programming language. But the point is, it's a lot of effort to set this up. That's why we only have 2 people right now who actually have this running. But once you have it set up, you can write programs that would take you days in minutes. And before I started working at Northeastern, I worked for Philips and a couple other biomedical companies. Typical development group would have like 3 electrical engineers, 3 mechanical engineers, and 30 software engineers. because software was always the limiting step that took, and everybody else had to wait for the software before they could test what they've designed. So the way to accelerate things is to accelerate the software. And I'm sure you probably use software that you buy to do whatever you need to do. So if ever you also probably found out there's times when the software you bought doesn't do quite what you want. I used to do plenty of animal studies myself, and a lot of times I had to end up writing my own code. And to be honest, I hate writing code. I hate programming. I've been programming now for well over 50 years. If you know what a Hollerith card is, and you probably don't, there's these little cards that you punch that create the program, and then there's a card reader that reads the cards and puts a program into a computer. Now, not computers like this, but computers that were like this. So this is just a very simple example of, I'll tell you what the program does, and then we'll talk about how it's made. So at Northeastern, as freshmen, they're taught how to program in C language. If you don't know what C language is, don't worry about it. But they have to write a program that you have a square Arduino board just that I can hold up. You have just an Arduino I can show people. Okay, yeah. So this is the board that we're programming. It has a microcontroller on it. So what's a microcontroller? It's a dumb little computer that runs about 500 times slower than the computer in your laptop. Your computer in your laptop does things in bunches of 64 bits. A bit is just a 1 or a 0 at a time. This does things in 8 bits at a time. So it's a lot slower, 500 times speed and 8 bits instead of 64 bits. But so we're gonna make a graphical program that runs on this. And here's what the program does. So this is the assignment. So when the students at Northeastern, as freshman engineering students, they're asked to create a program that has a program that there's 2 switches. So I think on most of the boards here, what color are yours, Elizabeth? What color are the switches and the LEDs on yours? What? Blue and yellow? Okay. So it has two buttons, a blue button and a yellow button, and it has 3 LEDs, a blue LED, a yellow LED, and red. Yeah, I think mine are the same. So actually I have, I think the same, blue, I'm not sure it's blue or green, but it doesn't matter. So when you press the blue button, the blue LED lights up. When you press the red button, the red LED, or we don't have a red, we have a yellow button, the yellow LED lights up. When you press both buttons, both the blue and the yellow, and a third LED, the red LED light up. Is that right? Did I say anything wrong? So it's a really dumb little program, but if you've never done any program before and you have to use what's called the Arduino, these are called Arduino boards, by the way, because that's the name of the little microprocessor on them. It would take you a few hours to do this. Starting from I don't know anything to how do I make a program. And the program would be about, 40, how many lines long?
They say 40 lines.
Yeah, 40 plus lines of code. So basically we're gonna create the same code that fits in here by just doing dragging and dropping little graphical boxes. And it's I wish every one of you had a computer and could do this yourself, because it's much better to learn if you're doing it instead of watching me or Elizabeth do it. Okay? This is the microprocessor. it has a bunch of called digital input and output pins. So output, you can make any pin you want an input or an output. It can't be both an input or output. So two of the pins on this switch, in this particular one, it was green and red, not yellow and blue, but that's besides the point. And so these, if you're enough of an engineer, if these switches are open, then this point is at ground. And if you know anything about Kirchhoff's law as an engineer, you would know that. If you don't worry. This is at 0 when the switch is open, but then, you know, plus 5 volts is equivalent to a 1. So when we close the switch, we force the value at this point to be 1. And the same thing for here. So we can, by pressing the buttons, we can make the input that these two pins read be either 0 or 1. So that's the only thing you have to worry. And then we're creating a program that says if pin 2 is a 1, then turn on, you know, this is an output pin, turn on, this is an LED, this is a symbol for a light emitting diode. Turn on this LED. If you press this button, then turn on this line to light up this LED. And if I press both buttons, you know, go ahead and light both of these, but also light this third LED. So that's all you need to understand about what we're trying to do. And that's the level of engineering you need to understand. We're trying to make just enough logic to do this very simple thing. Any questions about that, about where we're trying to go? Okay, so you can look over Elizabeth's shoulder, or you can come up and look at my computer, or you can look at the screen, whatever works. You have any other ways? But you need more than MATLAB at this point. So let me explain what this is. So there's a library. There's a library of these boxes in this program, and you just let me show you how this works. We'll start from the very beginning, okay? Yes. So the point of this is I don't want you to think about MATLAB. I want you to think about what I just told you. What do we have to do to make this program work? So what's the first thing in this program that needs to happen? So to make it do something, what do we need to do? What do you need to do one of the things to make the program do something? Speak up. Speak up for my old ears. What did you say? I'm not sure. Did you say you have to press one of the buttons? Did you or did you say something else? Huh?
I said you do a diagram.
No, I'm not. So you're asking how you create the program. I'm asking, what do you need to do? I'm not clear what I'm asking. Suppose you have the program and it's running. What do you need to do to make it do something? The $1,000 answer. You need to press a button. You need to either press the blue button, the yellow button, or press both buttons. So we have to tell this little stupid computer, read whether that button is pressed or not. So we need, these buttons are connected to what are called digital input lines. Okay, so I have to first thing I have to do on my program is put a block that says digital input. Okay, so if you watch, I'll show you how long it takes to do that. And the hardest part is finding where the digital input block is in the library. Just finding it, but I know that. So can you guys, I hope you can see what I'm doing up here. If you want to come closer, that's fine. Not many, okay. Simulink is a graphical programming language, essentially. You can do simulations, and maybe this afternoon we'll do that. or you can program things like these little Arduinos with Simulink. So you bring up MATLAB, and if you've installed Simulink, you'll see a choice that says Run Simulink like this. Okay, so I'm going to bring this up, but then I'm going to make it all disappear. And we'll start from here. Then you bring up Simulink, and this is why I wanted to skip this part, because mostly it's waiting for the little things to finish doing what it's doing. Okay. So like I said, the first thing we need to do is read buttons. And to read what you press on the button, so the buttons are essentially, it's a 0 when you're not pressing it, and it's a 1 when you are pressing it. So you need something on the on your computer that can read the buttons. And that's called the digital input, because it's reading a 1 or a 0. So you go to the simulation tab here, and this library browser shows you all the different things you can put in this model. And since we're using Arduino, we go to this one way down here that says Simulink support package for Arduinos, common things. And if you scroll down here, sure enough, there's something called digital input. So all you do is you take the digital input block and you drag it to your model. So this is like a lot of photo editing or things where you drag and drop things. That's all you're doing. So I know I need 2 of these because I have 2 buttons, right? So I have one there. Let's drag another one. And I know, because I've wired up the board, that the pins that these 2 things are connected to are pins 2 and 4. So I have to tell it that this Arduino input is connected to pin 2. And this one is connected to pin 4. Because I've already wired up the little circuit that does this, and I know how I connected it. Whatever pins you connect the buttons to, that's what you have to tell the Arduino. So the Arduino knows which pins to look at to read the buttons.
So what he's doing is that, when you look at Arduino, you can see that Arduino has the input and output pins. We have the both digital pin and the analog pins.
Yeah, so
Each pin has its number. So if you can just raise the Arduino, the letter, you will see the pins there. So what he's doing is that he assigning the pins. So that's what he's doing.
yes. So Elizabeth, you can show people where the pins are that we're wiring things to. Or you can come up here and I'll show you if you want to look.
We have some in front of them.
Okay, I don't know. At the other places, I don't know what they're looking at. Yeah, okay. So those are the 2. These 2 blocks basically generate the programming code that lets you read the state of those 2 inputs, whether they're 1 or 0. All right? And if you were doing this by writing, in a programming language, it would probably take you 5 or 6 lines instead of for each one of these, okay? Output pins. So right below in this block, below the digital input is a digital output block. So we're going to drag 3 of these over. Okay, and these 3 pins, because I built the little board that they're connected to, I know that they're connected to pins. You have to say OK or apply. And I can't tell you how many times I forget to do that. So now it says this is pin 3. You double click on this one, change it to pin 5. And the last one's connected to, the LED is connected to pin 6. Okay? So now we've defined the pins that are the output pins that the 3 different color LEDs are.
On it, then I will explain to them then. So
What?
now you can see that when you put your arrow on it, you can see the digital what? The digital output. You understand? So this and this are going to perform. They are going to perform an output operation. The output operation basically depends on the what? On the component that you are using. So you know LED, what does LED do?
All you know is you're sending either.
So one is going to be an output. So this is where the LED connections are going to be.
Okay. So now all we need to do is connect these inputs and outputs in some logical manner. I mean, if you're really a good, you know, you can label these so you know what's what. But for now, so if this one is on, this is our blue button. Let me see, I'm trying to get it. The hard part is getting it to let me type things. There we go. So I'll do it for this one, but you can label these with anything you want. So I can call this one blue button. All right, I'm not going to do all the rest. This is the blue button, this is the red button, this is the blue LED, this is the yellow LED, and this is the red LED.
So the limit is, most of you are programmers are familiar with when you are supposed to assign data types. Then you assign a name just similar as. So that's what you do. So just referring the blue leg as the word, as the pin2. You understand? So assign that.
So for those of you who are not engineers, I'm going to change the shape of that block.
I think this one is okay. This one is okay.
So now it's more obvious. That's an AND block, okay? So all we do to make the red LED light up is we say if the blue button's pressed and the yellow button's pressed, then we want the red LED to light up. Okay, that's the program. I've just programmed this, which I told you would take 40 lines or more of code by making 5 boxes, actually 6 boxes, and a few wires. And I've done the equivalent of writing that program. And now MATLAB or Simulink is going to turn this diagram into C code. And then it's going to load it into the Arduino. And unless I wrecked everything by shutting everything off and turning it down, all I should have to do at this point, and it'll take a little while, is click this button that says Monitor and Tune, and it'll start creating this program. And in a minute, it's going through all the things it needs to do to run that. And you can click down here if you want to see things that you don't, the main thing you want to make sure is that this little block that tells you what it's doing doesn't say error, because then you did something wrong. And honestly, I would be much happier if you were all doing this and I was just walking around helping you. This is not a good way to teach. But eventually, so it tells you it's generating code, and eventually it'll say it's transferring the code to the Arduino, and then it'll start running the program. So after I've talked and all this, I'm going to ask you, we're going to try to change the program. And I'll ask you guys how we can change it. I don't know how light are we supposed to run this? So, but if you actually were writing code, this would take you hours. And you saw I just did it in how long, even explaining every step in 10, 15 minutes. So that's the point. The software development should move 10 times faster than it did 10 years ago. And you only need 2 or 3 software engineers, not 30. So you can do I mean, this is simple, but you can do very complicated things like this.
Is this used like in real industry purposes.
So when I worked for, so are you asking, people are starting creating products this way, but also AI, I'll show you something near the end where you can go to ChatGPT and you can say, create me an Arduino program that when I press the blue button lights the blue LED, you know, just in Word, and it will create an Arduino ID program that does extend. The bad thing about this is MATLAB and Simulink are not cheap. You know, to me, I mean, well, the reason I like this is because this is, if you're an engineer, this, you don't think about code, you think about this, right? So, you know, to me, this is how I think, so I like doing things like this. And I hate writing code. So yeah, so people, you know, industry is leery because they're not 100% confident that this is going to be what they want. So there is a way where once you do this, you can have it generate the C code, and then you can have somebody look over the C code and believe that it's doing what you think it is, and then install it. You know, it adds an extra step, but there's still, but over time, people will realize that, you know, the higher the level, the more likely you are to get things right. Well, when you write line by line code, you're more likely to make some stupid mistake, like leave out semicolon or something like that. This, if you don't do everything right, is basically yellow paper.
So it is going to this was being generated.
How do you, that's another lecture. You need to install something else. This guy will tell you all about it. This is
next workshop. My next one, and then next workshop.
So this is Dr. Sandy. I've known him since the first time I came to Ghana. We did something similar at University of Ghana back then, right? Yes. And almost exactly the same thing. And he is one of the smartest guys I know in Ghana. He laughs, but I really believe that. Yeah. So he ran a lab, not a whole lot, but a lab like this. He now runs and owns his own. So let me show you what I had 2 slots at the beginning. And
Oh, sorry, sorry.
Okay. Thank you.
You go around.
pardon?
You go around.
You want me to go around?
I want to start.
Okay. Let's do that. So, okay. I'll go around and ask questions. And then, so, anybody want to ask me anything? Questions you're afraid to say because you think you're too dumb? It's okay to ask. So, Douglas.
Yes.
We have some stuff to do.
Yeah.
You know that.
Yes.
I didn't realize you and looking together. Patrick, I didn't know you were like that.
It's not a friend.
Yeah.
Bring
No, he says you're his brother.
Yeah, that's it.
So you're looking at how to install this. So just know that because you don't have a fast internet connection here. I at home I have like I measured how fast the internet was. About 15 megabits per second. So at home I have 300 megabits per second, and it takes me 20 to 30 minutes. So 300, so multiply that by 20. Able to run this? I got one besides me. Yeah, Elizabeth. But you can all get a 30-day free trial of MATLAB. I don't think this will work with the online version. I mean, I have never used it, but I don't know if you can do like the Arduino add-on with the on. I have no. Can you run Simulink in the online version?
I think you have the hard copy. You know that the one we did at NFA. Yes. So can you open it here? I think AI is the actual software.
So if you're asking me about what you can and cannot do with the online version, I don't know. If you work for Northeastern, everybody has a license. Yeah. So, but here, I don't know. If you guys want to do this, you should ask your teachers and deans and whoever, say, we need this. So what MathWorks, the people who make this stuff do, is they make it fairly, not cheap, but less expensive than what they charge industry. So the idea is to get you hooked on all their software while you're in college, so that when you go out and get a job somewhere, you say, I need MATLAB. And then they get their money from the company.
The MATLAB story.
So yeah, I don't know. You can try, but I don't believe you can run the Arduino thing from the online thing. So nobody wants to ask me anything, then I'm going to start asking you guys questions. Okay, so let's change this program. So right now, the way this program works is if I press the blue button, the blue LED lights. If I press the yellow button, the yellow LED lights. And if I press both buttons, all three LEDs light, right? Hopefully you've all seen that. If you haven't, come up and do it. I want to change the program so when you press both buttons, only the red LED lights. So what do we need to do to change the program to do that? You guys, think about it. This is not engineering, it's just logic. How do we have to change this diagram so that when I press both buttons, then only the red LED lights? So anybody have an idea? Everybody, let's start with it. Do you understand what I'm asking you? You can touch that, I don't care. I don't know if she cares. So what do we need to do? Come on, this is not hard. If I want it, when I press both buttons, how do I make it so only the red LED lights up? How do I need to change this program? Come up here and talk, because otherwise I don't think everybody can hear you. I know I'm putting you on the spot, but go ahead, come up here and. And you can help me to change the program. Come on, we're going to do this together. You want to? Yeah, sure. I'm happy to have you do that. But first, you have to explain to me what you want to do. You can be in power. Yes, I don't. So tell people what you think you need to do.
All right, so
Let's go back to the picture so you can point to things, okay? Okay, so this is our current program. So that's what you think it's just a picture, but it's really a program. So how do you want to change this program?
now when you press the two switch, only red.
So right now, this is blue, this is the blue LED, this is the yellow button, This is the yellow LED, and the one connected to the AND gate is the red LED. So the only time that works, when we press both of them, the red LED goes on, right? But what we're saying now, when we press both, we don't want this and this to go on, right? So how are we going to change this?
Maybe we need to disconnect the end.
So you're right. So when you press them both, you don't want this message to get sent. So what's the logic? It's this is pressed, and so think about when you do want this to light. You want this to light only when this one's pressed, and this one is what?
The yellow.
The yellow, yeah, but what state do we want yellow to be in?
When we press yellow, only yellow should light.
So, well, no, so when we press, no, when we, so I'm asking you about the logic. When do we want yellow to light in terms of the state of both of these? This one is pressed, and this one is in what state? Pressed or not pressed? You only get two choices.
Yeah, you don't
Not pressed. So you want it to be this and not this.
Yes.
So that's what you want. Instead of an AND gate, you want an and not and, right? You want, so there's, come sit, no, you get to do this. This is not rocket science. So what we're going to do here, so I'm left-handed, so can you do this with your hand, or you want me to do what you say? We want to disconnect this to start. Oh, first of all, we got to stop the program.
So we want to, when we press the two.
So does everybody understand what he said? He said, we want the yellow to light only when yellow is pressed and blue is not pressed. So we need some more logic in here to make that happen.
Mark,
Yeah.
he has not got the question correct.
So your question is, I'm going to show you what you need to do.
Okay.
So the first thing you need to do is disconnect this guy that's connected here. So you just click on this and hit delete. So I already clicked on it. Just hit delete. It's on the computer. Yeah, and it'll, okay. Mm-hmm. And then we'll click on this one too, and you can delete that one.
Yeah.
Okay. So now we want to do this and not this, right?
Yeah.
So you're going to need two more AND gates. I never remember how to do all this stuff. Copy, and then you can, just like anything else, you can say paste. And try hitting Control V, or yes, go ahead. No, we already copied it. Do a Control V up here and say, okay, so here's an AND gate, and then we'll figure out how to negate them in a second, but you need another AND gate down here, so hit Control V again. Okay, so now the question, we need to, oh, you got too many now. Just hit delete to copy that and hit delete.
Yeah.
All right, so I mean, this is like a million other graphical programs, right?
Yeah.
So now you need to do the not of these so you know when they're off to put into the AND gate, because you want it to be this and not this. So let's try, and I forget what the name of, try typing invert and see what it says. Yeah, or just try invert. We'll see if it's right, otherwise we'll search for it. And hit return. Just, no, that's backspace.
Yeah. So what do you want?
So just hit return, that's all. Let's see. No, that's not what we want. So let's do it this way. The hardest thing about this is finding the things you know exist. So simulation, to find these things, library browser. How do we get rid of this? Just wipe it out.
So go ahead.
Yeah, I know, but it's, okay, so, all right, this is not part of the Arduino support, it's just part of regular Simulink. So Simulink. Let's see if it's, well, it's still, oh no, it's running. So go ahead and try it, see what happens. Live dangerously. Okay. Now press both of them and let's see what happens. Yeah. All right, so you can come up here and see this does just what we said. When you press the yellow button, the yellow lights. When the blue button, the blue lights. And when you press them both, only the red lights. Okay, sorry. But you can see, you know, to change something like this is not very hard. The hardest part of doing this was finding the NOT gate in the library. You know, there's so many different choices. Sometimes it takes a while to figure out, to find the things you're looking for.
We are familiar with, we still remember in our schools, something like a combination logic. You understand? Whereby we can able to prove this, know the output that we are going to get. So basically, assuming that if here, let's say, basically here is 1, basically, what are we going to get here? So that's a kind of principle that it makes it very, very simple. No writing of code. No writing, just understand the logic.
So I guess my point is you don't need to be an engineer to understand it at this level. Mm-hmm. Anybody who can think a little logically should be able to do this kind of stuff. What you need is somebody who knows MATLAB and Simulink to install the software for you. And so you can hire Patrick, or where's Douglas? Where'd Douglas disappear? Oh, you're hiding over in plain sight. These are the guys in Ghana who know how to do this kind of stuff.
So, as I said, you can go to charts. Now, because of charts, now software engineers is gradually failing. You can just go to charts. Just prompt it to get a full of what? You don't need to be a software engineer for you to write a code because of charts. You understand?
So the one thing, and you can try this yourself, go to ChatGPT and say, write an Arduino code that when I press the blue button, the blue LED lights, when I press, that it describes in words what this does, and ChatGPT will generate the code that works. I've done that. So the bad thing about this is, 1, it's complicated to install, 2, it's expensive. But the thing I like about it, it pictures the way an engineer thinks. At least it's the way I think. Is it the way you think, Douglas? Yeah, we don't think in lines of code. We think in what we want the program to do. So for us, this is but ChatGPT will write the code, but it won't explain what it's doing to you. So, but it's, basically you can generate code for free with ChatGPT. You have to be smart enough to know that it didn't make any mistakes, though.